Hello everyone and welcome back to my channel. Now in this video we are looking at standards. Now it's as if based on the outline or the course content I gave to us, we're trying to run far, okay, because we have about 11 sections and this is already the second section, which is on standards. Now the first section was just one video because it's just the big picture behind integration. That's why it's just one video. But this section is going to be quite different, and other sections that are to come are also going to be quite different, because in this section we are going to be looking at standards, and apart from looking at standards we start solving questions, okay, and I know that's what you guys are waiting for. You want to start solving questions. So what we mean by the standards, what we simply mean by this is you have a particular formula, a particular way of doing things. That's what simply is standard. That's what standards are generally. You have that whenever you see something in a particular form, then this should be the output you're expecting. Okay, so that's what we are basically going to look at here. Now there are a whole lot of standards, but what I'm going to be doing here is to give you the main standard, those common standards that you're going to encounter. Okay, the first one we have is the power function. Now when we talk about the power function, we're looking at a function like this. You want to integrate ax raised to the power of n. This is called a power function. Now when you integrate this, what are you going to get? When you integrate this, basically you should have, just to increase the power by 1, from the power being n, you make the power to be n plus 1. Okay, but that's not all. You divide that result by that new power you have. So you divide ax raised to the power of n plus 1 by the power which is n plus 1. But as usual, since this is indefinite integral, since there are no limits, you include your plus c. Okay, but now this formula we have here is not general. It's not general because there is a restriction. The restriction is simply you can't use this formula when the value of n is equal to minus 1. So this formula is valid in as much as n is not minus 1. So I know what you'll be thinking is, okay, if I can't use it when n is minus 1, what will I then use when I have n to be minus 1? You're still going to use this power function. It's still called the power function basically, but this time around you're going to apply a little bit of indices. Instead of you having x to the power of minus 1 because n is minus 1, you express that as 1 over x. And if you recall from your derivatives, when you differentiate, there's a function you can differentiate to get 1 over x, and that's your ln x. So since when we differentiate ln x, we have 1 over x. We're trying to do the reverse here. So it means if you integrate 1 over x, you should get back your result as ln x. Now when you talk about ln x, it simply means the natural logarithm. That's what ln means. Natural logarithm is simply log where the base is e. E is a constant. E is called a Napierian constant. Okay, now I've not said it, but please, while I'm doing all of this, it will be a good idea. Okay, I know you have the video with you already, but it will be a good idea you bring up a sheet of paper or your jotter, your writing material, and then you take down these things. Okay, because it's not everything I'm saying that I have on the slide. So the slides are only showing you the key points, and every other thing I'm just saying them. Okay, so it's better you take them down. Okay, so that's for the power function. Now next we have trig functions. Now there are a whole lot of trig functions, but like I told us in the introduction, that I'm going to give us the major ones we are going to be encountering, the ones we are going to be seeing. Other ones, in the process of solving questions, we are going to look at them. The first one we look at is the sine function. Now if you recall in derivative, if you differentiate the sine function, you get cosine. If you differentiate cosine, you have minus sine. So here, when you integrate sine function, you're going to get minus cosine x, then as usual plus c. That's for the sine function. Then still on the sine function, what if you have sine ax? You integrate sine ax, what will you get? You're still going to get minus cos ax. The only difference is now you divide your result by a. Same thing goes to the cosine function. If you integrate cos x, you're going to get sine x. But when you integrate cos ax, you're going to get sine ax all over a. Okay, that's for the sine and the cosine function. Then we also have for the sec function. Now, when you differentiate tan x, you get sec square x. So the same thing, when you integrate sec square x, you're going to get back tan x. So whenever you integrate sec square x, you get tan x. Then your plus c is also there. Now we have the exponential function. I'm going to treat the exponential function in two phases. The first is when you integrate e raised to the power of x. Now whenever you integrate e raised to the power of x, your result is still going to be e raised to the power of x plus c. But what if it's not just e raised to the power of x? You have e raised to the power of ax plus b, and then you integrate this. Okay, in that situation, your result is going to be e raised to the power of ax plus b all over a. Similar to the sine function where we divide by a. Here we are dividing by the coefficients of x here. That's what we are dividing by. Okay, so that's what we have there. And thereafter, if we have the constant, when you integrate the constant, what you're going to get as your result will be, all we did was we have this constant, we are integrating this constant. Okay, so you can see it is still that constant we have here. The only thing we are doing here is this, that we are actually attaching x to the constant. Then we have a plus c, and if you recall, we said c we have there is called the integral constants, and you can use anything to represent c. Okay, so these are some basic constants we have, some basic standards we have when it comes to integration. Now, like I said, there are other standards, but those ones we are not just going to state them. We'll solve them out. While we are solving, we are going to see those standards. Okay, so in the next video, what we are going to be looking at are a couple of examples. We are going to be solving some examples that is going to make us understand all the standards we've discussed so far. Okay, so as usual, if you have any comments, you can put it in the description. Okay, if you have any question, you go ahead and ask, and I'll see you guys in the next video.